In this question, we are given a section of an addition polymer formed from two different monomers. First of all, I will find the repeat unit of this polymer. Start from the first carbon on the left. I draw an open bracket. Up to this part, I draw the closing bracket. The part of this section of addition polymer in the green bracket will be the repeat unit of this polymer. You can see that the next part of this section is repeating the structure in green bracket. Now let me remove the rest of the structure which is not a part of the repeat unit so that we can focus on the repeat unit in the green bracket. So again, this addition polymer is formed from two different monomers. And fortunately, the question tells us that one of the monomers is propene. Propene has 3 carbons. Since we are given the section of the addition polymer in skeletal formula, so I will convert this to skeletal formula. So this is the skeletal formula of a propene molecule. When we have many propene molecules react with one another, a polymer will form. Pi bond in the monomers will be broken, so no more pi bond in the polymer that is formed, and this monomer residue of propene will join the other monomers. So I show these two dangling bonds to show how this part is bonded to other monomer residues. By looking at this polymer structure that is formed by propene monomers, comparing it with the structure of the addition polymer in the question, I can see that this part, which I colored in red, came from the propene monomer. The two dangling bonds where the monomer residue of propene are bonded to other monomer residues. So now I am going to color the part which came from the other monomer. So the part in blue came from the other monomer. This part in blue contains a double bond between the two carbon atoms in the middle. This tells us that the other monomer is a diene. This rules out B as the answer to this question. Now, why the other monomer is a diene? Because when diene molecules undergo addition polymerization, two pi bonds in the molecule will be broken, leaves only one pi bond to be formed between two carbon atoms in the middle. If you would like to know more about how the pi bonds are broken and a new pi bond is formed between the two carbon atoms in the middle, you can watch one of my previous videos on the addition polymerization of dienes. Now I'm going to use the diene molecule in A as a quick example. So this diene will undergo addition polymerization. We use many monomer molecules. Two pi bonds will be broken. One new pi bond is formed between the two carbons in the middle, the two dangling bonds. An addition polymer is formed from diene monomers. Now let's go back to the addition polymer in the question. So the part that is colored in blue came from the other diene monomer. Now let me isolate this part without the dangling bonds from the structure so that we can work on it and find the diene monomer. So from the example, we know that this pi bond is formed after the addition polymerization. So let's remove this pi bond and add two pi bonds which are supposed to be in the original diene molecule. So now we have found the structure of the other monomer. Let's compare this structure to the answer in A, C, and D and see which one matches the structure of monomer that we have found. For carbon atoms, carbon number 1 is bonded to an alkyl group. Same goes to carbon number 4. So the answer is D. Carbon number 1 and 4 are bonded to alkyl groups. The answer to this question is D.